The essential question today is how can you recognize a geometric sequence from its graph? A geometric sequence when the next term can be derived by multiplying the previous term by a number. The ratio between consecutive terms in a geometric sequence is called a common ratio. And geometric series, the sum of the terms of a geometric sequence. Tell whether each sequence is geometric. So the first sequence, when I look at it, is 6, 12, 20, 30, and 42. If I try to find a common ratio, which means any term divided by the previous term, 12 divided by 6 is 2, and 20 divided by 12 does not equal to 2, so this is not a geometric sequence. So let us look at the second example. 64 divided by 256. Any term divided by the previous term is going to be 1/4. And 16 divided by 64 is also 1/4. 4 divided by 16 is also 1/4. And 1 divided by 4 is also 1/4. Therefore, this sequence is geometric with a common ratio of 1/4. On the next slide, you will have your first set of monitoring progress problems. So please work them out before you move on to the next slide to check your answers. On this slide, we are going to talk about the rule for a geometric sequence. To derive the nth term in a geometric sequence, you need to take the first term and multiply it by the common ratio to the n-1 exponent. An example for this is if there is a geometric sequence with a first term of 2 and a common ratio of 3, then we can write the equation for the sequence as a sub n, so the nth term equals 2 times 3 to the n-1 exponent. On this slide, we actually are going to write the rule for geometric sequences. And then once we wrote the rule, we are going to find the 8th term in this particular or these particular sequences. So in the first one, I write my term numbers or positions above each of my numbers. And then I'm going to look at what's happening, what's my common ratio. So every time I multiply by 3. So I know that the common ratio is going to be 3. And the first term is going to have a value of 5. So now to write the equation, a sub n equals the first term multiplied by the common ratio to the n-1 exponent. So a sub n is going to be 5 times 3 to the n-1. Lastly, we'll find the 8th term. So a sub 8 is going to be 5 times 3 to the 8 minus 1. So the 8th term is 5 times 3 to the 7th power. So the 8th term is going to be 5 times 2187. So the 8th term finally is going to be 10,935. So here is the value of the 8th term, and here is the equation for this particular geometric sequence. So now let's look at the second example. So in this example, the first term is 88, the second term is negative 44, third and fourth terms. So again, I'm going to look what's happening. How can I derive the terms? So I am going to multiply by negative 1/2, multiply by negative 1/2, and multiply by negative 1/2. So the common ratio is negative 1/2, and the first term is 88. So again, the equation a sub n equals a sub 1 times r to the n minus 1. So a sub n is going to be 88 times negative 1/2 to the n minus 1. So this is our equation for this particular sequence. Now we are going to find the 8th term. So that's 88 times negative 1/2 to the 8 minus 1. So the 8th term is 88 times negative 1/2 to the 7th power. So the 8th term is going to be 88 times negative 1 over 128. So if I reduce the fraction after multiplying, which is negative 88 over 128, the 8th term is going to be negative 11 over 16. The next slide will be a monitoring progress problem for you to write a geometric sequence and to find the 9th term. So please do that before you go to the next slide to check your answer. So in this problem, we are given one term of a geometric sequence, the 4th term, which has a value of 12, as well as the common ratio, which is equal to 2. So the general form of the equation is a sub n equals the first term times the common ratio to the n minus 1. So I look at the given information. I know that a sub n is going to be 12 because we are talking about the 12th term, and n is going to be 4. So this is going to be 12 equals the first term, which I don't know. I know the common ratio is 2. I also know that n is 4, subtract 1. So 12 will equal to a sub 1 times 2 to the 3rd power. And from here, I need to do the 2 to the 3rd power, so that's going to be 8. And last, I am going to divide both sides by 8 to find my first value. So the first term is going to be 3 over 2. Once I have the first term and I have the common ratio of 2, I can write the equation a sub n is equal to 3 over 2 times 2 to the n minus 1. This will be the equation for this particular sequence. Now we need to find the first 6 terms of the sequence and then graph them. So the first term is going to be 3 over 2. The second term in the sequence is going to be 3 over 2 times 2, which is 3. The third term is going to be 6. The fourth term is going to be 12. The fifth term is going to be 24. And the sixth term is going to be 48. So let's go by 4s on our coordinate plane. So each square will represent 4. So this is going to be 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64. So let's go ahead and write the x-axis. Let's go by ones. So I'm going to write just the first 6 terms. So the first number is going to be 1.5. So if one square is 4, 1.5 would be about here. And then the next number is 3. And then the following number will be 6. The next number is 12. The following is 24, 16, 20, 24. And the last number is going to be, sixth number is going to be 48. It clearly shows from the graph that we are dealing with an exponential function. So let's write that down, exponential function. So a geometric sequence has a graph of an exponential function. In this example, we are given two terms in a geometric sequence, and we need to write the rule for the end terms. Neither one of the terms that are given are the first term, and we don't know the common ratio either. So we know that the geometric sequence has an equation of a sub n equals a1, or the first term, times the common ratio to the n minus 1. So I'm going to substitute into this equation. The first thing I will do, substitute from the second term, which is 12. So a sub n is going to be 12, a1 times the common ratio, and n is 2, so it's 2 minus 1. If I simplify this, I get 12 equals a sub 1 times r to the first power. Now I will do the same thing using the second term. So the second term given to me is the fifth term with a value of negative 768. So I'm going to have to substitute negative 768 for a sub n. Again, I don't know the first term, and I also don't know the common ratio. However, I know that n is 5, so 5 minus 1. Therefore, in a simplified form, is 768 equals a sub 1 times r to the fourth power. Now I go back to the first equation and I isolate a sub 1 by dividing both sides by r. So I will have a sub 1 equals 12 divided by r. Then I take this value and substitute it into the second equation. So negative 768 will equal to 12 divided by r times r to the fourth power. So now I need to simplify by r. So negative 768 will equal to 12 times r to the third power. Then I divide both sides by 12. And I get negative 64. So negative 64 will equal to r to the third power. And if I take the cube root of both sides, then I will end up getting r equals negative 4. So now I am going to find my first term. So the first term is equal to 12 divided by negative 4. So the first term will have a value of negative 3. And now I am ready to write the equation. So a sub n is going to be negative 3 times negative 4 to the n minus 1. The second video will start with some monitoring progress problems, so you can get started working on them before you watch the next video.